So today we will discuss the different aspects of artificial intelligence and cloud infrastructure. So why I selected this topic? So as all of you know that artificial intelligence is the new boom in the our knowledge industry. So there are various research groups which are working in building new advancements into artificial intelligence. But cloud is also is one of the component which is used in building different solutions because of, as you know, there is a lot of data is getting generated every day, every hour, every minute, and every second. As you can see, your typical mobile phone is a source of data for different companies. So we will start today with a title, Building Intelligence Solution for Medical Sciences using Artificial Intelligence and Cloud Infrastructure. So we will keep our examples close to medical sciences, so that will be easy to understand for this cohort. Yeah, and may feel free to interrupt me if you have any question, if you have any comment on a particular slide or a particular topic. So agenda for our discussion will be divided into three parts. First, the cloud infrastructure. Second, how to build a solution. And third is the AI landscape. So I believe you people are already aware with the few of the concepts into AI. But let me know if you want to stop me somewhere and we want to rediscuss the topics. We are starting with the cloud infrastructure. So, first of all, I want to know that how many of you have a prior familiarity with cloud technologies? You can reply in the chat window so that it will be easy for me to understand the comfort level of this cohort. Okay, so I am considering that this cohort is non from that technical background. So, uh, take an example: you have one PC on your home, and you used to work daily, and suddenly you are a project manager of one of the community based trial where your job is to create forms, gather information, save at one place, and after that analyze and publish your findings. So if your cohort is say 100 patients or 1,000 patients, or it's a community driven, so you have access to say 1 lakh people, and it's a short term project, you need to finish everything by say 30 days. Now it's not easy to build a entire solution on your own, on your home desktop, because of we will require a lot of computing power, we require the storage, and we require a particular solution which can enable your other team members who collect data from the community, which can directly fed into the system. So here cloud comes into the picture. So using cloud, you can build a solution which is deployed on the server. In your case, say your desktop. But because of we have a lot of information to gather, we need to process that information. So our desktop will not suffice to solve the purpose. So we have servers. But the major challenge with the server is the cost. If you don't want to invest that much because of you have some financial limitation of the project, so you can opt for cloud. So cloud is nothing, a shared infrastructure built by some companies over the internet, where you can save your data, you can process your data, and you can publish your data. Now coming to the types. So there are, by the generation of cloud, there are three types of clouds. One, primary cloud or private cloud. Second, the public cloud. And the third is hybrid cloud. So uh, private cloud is something when you have all, any question? Okay. So private cloud is something when all the infrastructure is available on your own campus. So carrying out the same example, suppose you are the project manager of a project where you don't want to store your data outside of SGPGI premise because of due to some legal restrictions or institutional restrictions. Institute or your funding agency is not allowing you to store data outside of SGPGI premise. So you will come to the vendor. So vendor are basically those companies who provide these services. So you come to the vendor and ask that, okay, we by the legal liabilities, we cannot opt for a public cloud. So just create a cloud in our own SGPGI. Then that is called a private cloud or on-premise cloud. So all the infrastructure is available within your premise. Second is public cloud. So as we can see from its name that it's a public cloud, and usually all the infrastructure is available over the internet. So it's not like that it's not safe or something, but yes, it has few limitations that we have in private cloud. So in private cloud, you have access to hardware, you have access to everything. But in public cloud, you have some limitations. Now coming to the third type of the model, that is called hybrid cloud. So taking the same example, so you are collecting data from community setting. Now you want to save your data on your campus, but you need to share your findings, your analysis with the funding agency. So all the data collection, data storage, data processing, that is done within the premise. So that is something private cloud. But for sharing those results with your funding agency, with Department of Health, you have created one output layer or a one visualization layer in a public cloud. So this model is called hybrid model, where some part of your infrastructure is available on premise and some part of your infrastructure is available online. Now we will take another example. So on the basis of services, there are multiple type of clouds. So we will take an example of a pizza eating. So suppose you want to eat pizza. So we will discuss considering this problem. And yeah, so we are seeing cloud from a pizza view. So uh, there are four situations. One, you want to bake your own pizza from the scratch. That means all the ingredients you will take by your own. You will cook pizza on your own at your own home, and after that you will eat at your own home. So this model is called traditional on-premise cloud service, when you have everything available in your own cloud, in your own infrastructure. The second one is you have bought all the ingredients from the market, but you cooked it at your home and you eat here. So that is called infrastructure as a service. So you are not buying or you are not using the entire framework, just you are hiring a part of it. So suppose you have a virtual machines. So virtual machines is something. So suppose suddenly there are 100 people who joined your team, and now you need to provide them computers. So it's not easy, because for a shorter period, if you are buying everything from the scratch, you are buying 100 computers from the market. So what you can do, you can hire infrastructure from cloud. So you can hire some 100 machines online, and your team can work for a month. And after that, once your project is over, you will just say to the vendor that, okay, no more requirement. So for this, you are just leasing those 100 machines. Now coming to the platform as a service. So taking the same example, so we bought the we asked our vendor, the company, to purchase all the ingredients from the market, bake the pizza and deliver it at your home. So this is called platform as a service. So what you are doing here, so initially what you are doing, you are hiring the infrastructure. After that, you are maintaining the platform. So now extending the same project example, what we are doing. So you have started the data collection. So now you have one option to build everything in your campus, or you have another option, the data collection platform, you can rent it from a cloud service provider. So the process of setting up the platform and running the platform is completed by the vendor. And as a user, what you are doing, you are just using that platform. So it's less in the cost because of everything is set up by vendor. You are just using that. Now the third option, software as a service. So here what we are doing. So right now, what was the last scenario, that pizza got home delivered and you ate it at your home? But what if you don't want to if you don't want to eat pizza at home, you went out to a restaurant and eat also. So what you are doing, you are hiring everything. You are hiring the base material, you are hiring the cooking process, and after that you are hiring the space where you want to eat. So this model is called software as a service. So here what happened, so most of you are aware with the Google Drive, and you have a Google Docs, you have a presentation service of Google. So all those are software as a service. So you no need to buy a software, no need to buy a machine where you will run that software. And after that, and after end of the day, it's a cost effective, because of if you are buying a machine, buying a software and running it, it will be most costly. Comparatively, you are renting everything. Now, what are the different component of cloud storage? So there are majorly three components: storage, computing, and the network. So the same example that we have, so you are a project manager and your questionnaire is done, or your community service, your community team is done, and now we are starting the data storage. So there are, as you know, there are two type of data: one structured data and one is unstructured data. So in structured data, you have certain questions, and after that your respondent will respond on that. So that is structured one. But you have unstructured data also. So what comes in unstructured data, like your ECG prints, like your X-ray, like you have MRI scans. So these are the example of unstructured data. So what first we need to do, we need to store all this information at one place. So suppose in SGPGI we are running a study. So we want to study the cancer pattern, and we want to build a solution, which AI solution, which can help our doctors to diagnose the cancer. So what will happen? So first of all, you need to come with the primary vitals. So what is the age of the patient? What are the other vitals, like its blood sugar and whatever you want to measure? So that is structured data. On the top of that, suppose the patient is coming again and again, and you are making a, a longitudinal study, and you are again and again taking the snapshot in form of CT scans. So that is unstructured data. So that is the first part of the cloud infrastructure. So storage. So you store structured and unstructured data. Now coming to the second point, that is computing. So now you analyze that data via a computing engine using a software. I mean, it's totally up to you and your institution which software package you want to use. You want to go for perpetual licenses, like you run Stata, you like SPSS, or some other perpetual softwares. You have SAS, or you have a compute engine based on open source softwares, like you have R, you have Python, and other platforms. So this computing engine enables you to analyze that data which you stored at a previous phase. Now coming to the third one, the network. So network security is the most important. because of typically the doctors deal with very sensitive data in terms of various personal identification information as well as different medical information that we store over the system. So network security is very important so that no one can intrude into our system and get access to that information. Now coming to the advantage and disadvantage of the cloud infrastructure. So first one is the easiest implementation. So suppose you have a sudden requirement that, okay, you need to finish one project within a week, and it's a community driven or a hospital based project. So you don't have time to buy hardware, you don't have time to buy softwares, installation and everything. So what you can do, you can just go to the cloud and push your requirement that, okay, I will require this amount of storage, I will require 5 machines and all. And within 5 minutes on a single click, all the infrastructure is ready for you. Second, the accessibility. So all this infrastructure is accessible from anywhere, just a connectivity of internet. So if you are at home or you are at office, you are traveling somewhere, you can access your cloud infrastructure from anywhere. Third, no hardware requirements. So I will rephrase this. I will say no physical hardware requirements. So hardware is there, but over the cloud. So you no need to have a physical hardware, a physical lab. So it's easy to maintain. Fourth one is cost per head. So suppose you have a 100-seater, you have 100 analysts in your team, which is analyzing data from cloud, and after that, the data is continuously coming from community setting or coming from office information system, or it's coming from hospital records. So instead of buying hardware from the market, you can rent it. So it will decrease the cost of the project. The fifth point is flexibility for growth. So the flexibility, you have a flexibility to grow. So suppose you are running a project, and suddenly you realize that you will require more memory or more storage to run your day-to-day operations. So in general scenario, what we need to do, we need to ask the IT team to upgrade. That comes with a huge cost and that takes time. Here you can, on a click of a button, you can scale up your solution, you can scale up your infrastructure. And the sixth one is the efficient recovery. So as you know that all the systems are very much, just a second, yeah, very much exposed to fault tolerance. So when I'm saying fault tolerance, what that means, your hard disk got crashed or your system got down. But in cloud, these things are eliminated as your entire infrastructure is copied multiple times over the network. So suppose you are storing data at a single place, so it's not like that it's stored there only. So there are multiple copies of it stored at different location. Obviously, it will be a within reason. So suppose you have hired a cloud which is situated in India. So all the copies of your data will be available, but within India. It will not go outside India. Now coming to a disadvantage part, the bandwidth. So this is the most important aspect of cloud computing, because of you are always connected via internet. So if the internet is lost, so you cannot access your cloud infrastructure. Second one is vendor lock-in. So as you know that you get in touch with any company for providing you this infrastructure. So you are always dependent to that company. The third one is limited control. So it's mostly your infrastructure is from the operational perspective, it's in your control, but from ownership perspective, it's with the vendor, the company who is managing the cloud. After that, restricted features and availability. So this is like you have asked your vendor to provide some XYZ softwares and you want additional softwares. So it's not easy to get in cloud because of that comes with additional cost. And now come to the security. So as we discussed earlier, on-premise cloud is more secure than off-premise cloud. Now coming to the point that why it's a good choice for building medical applications. So as you know that in medicine we have a huge data which is generating every day. As we discussed earlier, we have X-rays, we have MRI scans, we have CT scans. So this comes with huge space liabilities. So your each MRI and all these are cost around for 50 to 200 MB per scan. So suppose you are scanning multiple patients, so you will require exponential storage. So because of there is no restriction on storage on cloud, so it's not easy to maintain that infrastructure in premise because of buying storage. First of all, it's costly, and second, it's not easy to maintain. Both of the things here are taken care by the different companies. Second is first concept, first point why we will require cloud for our medical applications. So first is high availability. So most of your vendors guarantee almost 100% availability of your application. So suppose you have hosted an application over the cloud. So what will be it will be almost 100% available for the end users. Second is security. So that we have already discussed that it provide you different layers of security. If you are more specific about the data security, then you can opt for a on-premise cloud or you can opt for off-premise cloud. After that, what happened? The less upfront cost. So setting up the entire infrastructure of your own with comes with a lot of cost. In cloud, you no need to pay all the cost upfront. What you can do, you can rent, you are in a way you are renting the entire infrastructure. So that is why it's less in cost. Now the scalability, as we discussed prior, that if this all your solution is scalable, either there are 10 patients, 100 patients or 1000 patients, you can scale up your application on a click and that is available for more number of users. The same we discussed the quick setup and deployment. And after that, you have wide range of application implementation. So application implementation means, so suppose you want to buy one database server for storing data, machines for analyzing data, and after that you want to build one visualization layer for publication of your result. So in general, if you want to keep that in your own, so you need to buy everything. But here you have more options to select, and that is cheap also. After that, enable data exchange and integration from larger sources. So as we discussed earlier, so here we can integrate data from many sources. So the cloud allows you to fetch data from many sources, like you have file data, those are your scans, your ECG, MRI, etc. You have your structured vital data, which is stored in a database. And after that, you have data from a community trial, which is in form of other files. So what you can do, you can integrate all that data into a central location and you can analyze that. So these are the cloud service provider currently available in India. We have Amazon, that is Amazon Web Services. We have Azure, that is offered by Microsoft. Salesforce, Oracle have their own set of cloud offering. Then we have GCP, that is called Google Computing Platform. And then you have Alibaba. Now, before moving to the next section, that is the building solution. Any question in the cloud section? Okay, thank you. So now going to the next segment of this discussion, that building solution. So what is an AI solution? So basically there are three components of it. One, domain, second, research method, and the third is technology. So what domain stands for? So domain stands for the subject knowledge, the subject expertise, which is dealing with a particular type of problem. Second are the research methods. So suppose you want to build a solution which can help a doctor to identify that, okay, what will be the chances that a particular patient will get a stroke in next 1 month. So the domain, so there will be an expert committee of doctors which will recommend a particular type of trials. After that, we have research method. So in research method, a committee of doctors which will say that, okay, these trials will be done and data will be collected in this frame. And after that, we will perform a particular set of statistical and other methods for diagnosing or to predict that, okay, a customer might get a stroke in next 1 month. And after that, you have a technology. So once you build the solution, so you build solution for a smaller scale. You build solution on a small data, but when your solution go into the community or for use, then you have a larger user group. So suppose you build you build your solution on 50 patient or 100 patient, and after that that solution went in the market. Now thousands of people which are using that. So your existing infrastructure where you have built the solution will not sufficient for a larger customer base. So using technology, you can make that solution available to your end customer or end patient at a large scale. Now coming to the different methodologies. So there is something is called cross-industry standard process for data mining. So this is the most standard methodology which is used for building different solutions. So it's a majorly 6-step process. One, starting with the business understanding. So we will set up this process into a medical setting, and after that we will discuss. So taking the same example, what we will do, we will start with the business understanding. So here we have the problem understanding. So what was the problem? That, okay, we want to build a solution or a predictive model or a AI algorithm which can help to diagnose or to predict that a particular patient will get a stroke in next 1 month. The next step will be data understanding. So from the previous step, with the help of experts and others, we will collect the data, and after that we will go for data understanding. We will visualize data, we will do an exploratory data analysis, we will go for a hypothesis testing and test different hypotheses. Next, we will go for data preparation. So once we have explored the data, we know that how different variables are related to each other. Now we will go for data preparation. So data preparation is something where we prepare data or create new variables from existing variables. So suppose you have a variable that is called date of birth. You cannot directly use that variable into your analysis. So what you will do, you will create one more variable from that, that is age. The age can be used in your analysis. Now coming to the next part, that is modeling. So this is the most critical part, and majorly people suspect that this is the part where the solution build. So modeling is something you build algorithms, you build model to predict something. So from a classical perspective, we have regression, and from the modern computation environment, we have neural networks. In neural networks, we have different type of neural networks. Suppose We have convolutional neural network, which is majorly used in analysis of image data. Then you have recurrent neural network, which is majorly used for natural language processing. And we have LSTM, which is a special case of a recurrent neural network, and that is also used for time series based exercise. The simplest form of a neural network is perceptron. So perceptron is nothing, it's a graphical representation where you have multiple input variable, and after that a weight assignment, and the using activation function you go for a result. And after that the next part of the modeling is evaluation. So you evaluate your result, and you got to know that, okay, so suppose you build a cancer diagnostic mechanism. So while if you were evaluating the result, the sensitivity of results say 60%. So this is, we cannot say that, okay, this is a good solution. So we will go back, and after we will build the solution again. So the evaluation part comes with different matrices, like you check the sensitivity of the solution, specificity of the solution, what is the accuracy, etc. And once it's evaluated by the team of expert, it go for a deployment. Okay, so now the next topic is the AI landscape. So first of all, we want to know that, okay, I mean, I know most of you are already aware with these terms. So, but for the refresh, I want to discuss these terms first. So what is artificial intelligence? So basically artificial intelligence is nothing. It's a technique which enables machine to make some decision on the basis of historical data. Now coming to the machine learning. So machine learning, so artificial intelligence is a basically umbrella term. So machine learning comes under that. So what is machine learning? So machine learning are mostly very sophisticated statistical methods which enable a user or researcher to build models or build solution for a particular set of problem. The second part of it is deep learning. So what deep learning means for, so in there is a slight difference between machine learning and deep learning that we will discuss in upcoming part of this discussion. So deep learning is nothing that it's majorly based on the neural network architecture. It use multiple layer of neural networks and different set of networks for implementing a single solution. It might be a classical regression problem or a classification problem. So when I'm saying regression problem, that means you are trying to predict a number, a measurement. And when I'm saying classification, then it comes with the qualitative data that cancer is there or not. So this is the classification problem. So now this is for our researchers to how to start with the model selection or an algorithm selection. So you need to know that, okay, what kind of data you have or what kind of problem you want to solve. So first of all, if you are starting with a dimension reduction, so dimension reduction is something you have a lot of data. So suppose you are working with NFHS data or DLHS data. So you don't want to go for with 100% of data because of suppose there are 1,000 variables. So it's not easy to process and analyze 1,000 variables. So instead of that, what we can do, we can reduce the dimension of it, and we can create new variables which are the combination of those 1,000 variables. So after dimension reduction, we are set up on say 80 variables or 50 variables instead of 1,000 variables. So if the dimension reduction is the target and you want to go for a topic modeling or a probabilistic approach, then you can start with LDA. You have heard of it. If you don't want on a probabilistic side, you can start with the singular value decomposition. Else you can go for a principal component analysis. Second, you have responses. So there are two types of problems in machine learning or in artificial intelligence. One where you have response, the other where you don't have a response. So where you have response, that is called supervised machine learning problems. Where you don't have a response, that is called unsupervised machine learning. So take an example of it. So suppose you want to predict that, okay, a particular patient has a diabetes or not. So you have you have a response variable that, okay, a patient has diabetic or not. And after that, you have various predictors, like you have age, height, BMI, weight, etc., etc. So this is the data where you have a response. This is called supervise. And suppose you don't have the label that, okay, you have all the data, that you have blood sugar level, you have all the vitals, but you don't have the label of it, that, okay, the particular patient is a diabetic or not. So that is called unsupervised learning problem. Okay. So you have response, yes. Now, as we discussed earlier, you are predicting a numeric data. So if you are looking for speed, then you can go for decision tree, you can go for linear regression. But suppose you are more concerned about the accuracy of your solution, then you can opt for a random forest or a neural network or gradient boosted networks. Now, suppose it's not a numerical problem. You want to classify in yes, no, good, bad, it's a cancer or not cancer. So now again, it comes to the lower right side, lower left side of the portion. If you want the explainability in your solution, explainability means you need to analyze the individual contribution of different variables. So now you can go for a decision tree or logistic regression, where you can calculate odds ratio, where you can calculate other things. So you can explain your models to a layman or to a administration or to your funding body. Or suppose you don't have that challenge and you can go ahead with other algorithms. So you can take SVM, you can take random forest. So these are the basically black box models. So you give them certain type of input, they will give you output. But the solution explainability lacks. You don't have clear cut explanation that, okay, how much high blood sugar contributes to diabetes, or how your BMI contribute to diabetes if you are going with black box models. And suppose your data is very large, then you can go with a naive Bayes, or you can take SVM and other approaches. Now coming to the next part of our discussion, that is a deep learning. So usually how it happens that, okay, in our traditional machine learning methods, you have a set of input variable, and after that the researcher select some of the variables from that on the basis of some experience and some statistical criteria, and after that those features goes into the model and you get an output. So deep learning is a bit different from there, or your ANN or neural network based solutions. So here you just provide input. All the manipulation, feature extraction, and model building is taken care by the algorithm. And after that you get an output. Now, there is something is called transfer learning also. So that is the future of deep learning. We are already in a phase where we are using transfer learning, but still majority of researchers are using deep learning. So there are some predefined criteria for deep learning, a predefined task. So what we used to do, we used to create different kind of images. So suppose you have a X-ray. So suppose during the when a radiologist is taking X-ray, the patient moves from its original location. So now you have another type of image. So, and your solution will be as good as when you have different type of data, different set of images. So the more diverse images you have, you can predict your solution more easily. So those tasks are automatically taken care by the model. So you give certain images to the system will create different variety of edits to itself. So suppose you are giving it in a 0-degree position, so the system will try to rotate it to a 90-degree and create different type of images which will help you to generalize your function. So in how transfer learning is different from your traditional deep learning. So in traditional deep learning, you certain type of task which is performed by the user. But in transfer learning for a particular domain, all those tasks are automated and you need to just put the data. All other things are taken care by the algorithm. Now coming to the AI and cloud use cases, how you can utilize your cloud with AI. So first of all, the virtual assistants, like you have many examples in your real life, you have wearables, you have many virtual assistant in your mobile. You can use AI in research and advanced analytics, which typically start from various drug discovery. You have typical virtualization there is there, and you have a different kind of such sub-segmentation within the population that can be done. Then you have life coaching for personal health. So this is something when you want to create a personalized treatment plan or a personalized plan for a different set of patients that you can achieve using the AI and cloud. Then you have healthcare bots. So basically healthcare bots help different doctors and paramedical staff to give them advice that what to do in certain situations. So in that, so suppose the patient came to the hospital, his blood pressure is this, his oxygen level is this, and then you have certain type of questions. So you can put all the answer to the bot, and bot will suggest you that okay, what might be a possible problem and how to go ahead with a treatment plan like that. The same we are discussing at the next, that is diagnostic assistant and medical imaging. And after that, we have dictation assistant, we have drug discovery and creation, and we have cybersecurity. Okay, so and one thing that I want to reiterate here that most of the time it's AI is marketed as that okay, it will predict cancer, it will do diagnostic, it will go for a treatment and all. But I mean, personally, what I feel, AI is not going to do that all that. But yes, AI will help medical professionals to enable them making data driven decision. It will help the health workers, it will help the doctors, and it's not going to work as autonomously. So AI is always an assistance for the doctors. It's not like it's going to work at itself. Any questions?